In this next video, we're going to talk about what to do, or what if you can draw more than one correctly drawn Lewis dot structure for a molecule. Is it possible to draw more than one Lewis dot structure for a molecule? Let's take a look at this sulfur dioxide molecule as an example. If I was to ask you to write the Lewis dot structure for SO2, start off with the same 3 steps that we've done in the previous videos. Determine number of valence electrons. Both sulfur and oxygen belong to group 6, so 18 valence electrons. Sulfur is my least electronegative atom, so it's my central atom. I'm going to start to make my single bonds. 2, 4, so I've used 4 of my 18 valence electrons. Complete the octets of my outer atoms. And doing that, my outer atoms are happy, but I have not used all of my valence electrons yet. I've used 16 of my 18 valence electrons. I've got 2 more that need to be placed. Anytime you've got extra valence electrons after completing the octet, put them on the central atom. And so that would be a perfectly reasonable Lewis dot structure at this point. I've used 18 of my 18 valence electrons. My oxygens are certainly happy with 8 valence electrons. But my sulfur is not very happy. It only has 2, 4, 6 valence electrons. So we're going to look to see if we can share any lone pairs from an outer atom, and I see that there's 2 possibilities here. I could share a lone pair from the oxygen on the left, but I could also share a lone pair from an oxygen on the right. So which Lewis dot structure is correct? So both of these Lewis dot structures for SO2 are called resonance structures. They are equivalent Lewis dot structures for the same molecule. And many times resonance structures can be written for molecules that have outer atoms with lone pairs on them. Not always, but most times. Okay. So when drawing resonance structures for a particular molecule, we use this double-headed arrow in between them. In the next few videos, we're going to talk about how to determine which resonance structure is best with regard to formal charge and bond order. But for the end of this video, I just want to introduce the concept of resonance, being able to write equivalent Lewis dot structures for the same molecule using the rules that we have talked about previously. And in the next video, as I said, we'll use something called formal charge as well as bond order to speak to which resonance structure may or may not be the best one.